Alright, now let's go over part B of question 2 on the data analysis project part 3 assignment. So question 2, part B. This is a question about interpreting a regression result with a single explanatory variable. So you've already run a regression with a single explanatory variable in part 2. So you know how to do that, and part A is just asking you to report the equation and R squared value, which you also did in part 2. So you'll either use the same regression with the same variable that you did in part 2, or you could run another regression with a different explanatory variable if that's what you're interested in now. But part A should be pretty straightforward. So part B, I'm going to go over part B here. And these instructions, once you have your regression equation, this part is going to work the same way on a Mac or a PC. So these instructions should work for either of those. So in this case, if you had the data analysis tool pack, then your regression results might be on another worksheet here. But either way, just the first thing to do is make sure you know your regression equation. So I got it from this output, but if you're using a Mac, you might have used the slope and intercept commands. And in part A, you had to report the equation, so you've already got it written down. So I wrote the equation here, and then I actually wrote it out. So I'm just going to copy that, and I'm going to paste it near where I have my quartiles, my 5-number summaries, so that I can look at those at the same time. Okay, so now I've got my equation, and it's a regression predicting commute percentage by bike, so the bike share of commuters in terms of the gas price in the city. So I want to compute, in part B it's asking me to compute the predicted value of my response variable at the first quartile of the explanatory variable and at the third quartile. So basically I'm just plugging in the values here in the equation with my explanatory variable. I'm plugging in the values for Q1, first quartile, and Q3. So first I'm going to label this predicted value of commute for gas price Q1. Okay, and then I'll just put the results in this cell, but I'll type the same thing for Q3, and you don't have to do it this way, but this is one way to keep track of what you're calculating, make sure you don't get the numbers mixed up. And so this is pretty straightforward. All we're going to do is type in equals, and we're going to use this equation. So equals the intercept negative 4.8 plus the slope 0.05 times Q1 of, and make sure you got the right variable. So this is the gas price column. So Q1 is right here. It's 103.68. Okay, so that means that at the first quartile for gas price, I get a predicted value of commute, for commute of 0.38. So that means it's predicting that 0.38% of commuters are commuting by bicycle. And then the same thing for Q3 equals negative 4.8 plus 0.05 times, now Q3 is 116.8 right here, 16.8. Okay, so now I get a predicted value of 1.04%. So when cities have a higher gas price, when they have gas price equal to the third quartile, they're predicted to have higher rates of bike commuting. And I also ask you to interpret in part B whether you think this is a big change. So this is a change from the first quartile, kind of the left side of the distribution of gas price, to towards the right side of the distribution. So it's a pretty big shift in our explanatory variable. So the question is, does this seem like a big shift in your response variable? and this is very subjective, but in this case, 0.38% to 1.04%, because I know that the commute percent by bike only goes up to about 2 or 3% at the maximum in these data. I can say that that's a pretty substantial shift to go from 0.38 to 1.04%. So in that sense, these results suggest that gas price is an important predictor of commute percentage. And again, it's subjective, but you just kind of have to be able to think about those things, and it relies on a little bit of substantive knowledge of the topic that you're studying, that your data is about. So if you have any questions about that, let me know, but that's what I'm asking for in terms of whether that's a big change. And actually that's in part C, so it's right after you calculate this that you'd have to comment on that.